Hey everyone, welcome to my talk, Conversational AI 101 here in the Ibero-American Chatbot Conference. Just as a quick introduction, I am Xavier Portillado. I am Spanish, and you can find me in all my social media networks, specifically like Twitter, YouTube, where you can find this recording as well. Twitch, where I usually do live coding, and GitHub, where you can find all my open source projects. I am co-organizer of the DevOps Days Madrid, and I'm working as infrastructure team lead at VoiceFlow. I am Alexa champion and Google developer expert in machine learning. I love conversational AI, and you can find a bunch of information and articles that I usually write in my blog. It's xavidop.me, and I have also in Spanish a monthly podcast called Boztech. So yeah, and as you saw in the first slide, today we are gonna talk about Conversational AI 101. That means that we are gonna introduce you what is Conversational AI and how to create better experiences once you are creating like assistants, chatbots, like conversational AI applications at the end. So as I said, these are like my recognitions. I am Azure Content Hero, GitHub Star, Google Developer Expert in Machine Learning, AWS Community Builder, Alexa Champion, and also Auth0 Ambassador. So, conversational AI. What is conversational AI? Basically is the synthetic brain power that makes machines capable of understanding, processing, and responding to human language. Basically is the way or try to talk with machines in the more natural way, and of course using a natural language or human language. Okay, basically is when you are trying or when you are talking with a chatbot, with an assistant, and you don't even know that is a chatbot, an assistant, that is like a robot. Because the interaction is super natural, and yeah, that's basically conversational AI. When we talk about conversational AI, there are several processes that are involved that we are gonna talk about them in a bit. So here you have like basically the conversational AI process that you will often find when you are building conversational AI apps. Not all of them applies to all the conversational AI applications, but most of them applies to them. So for instance, if we are talking about a conversational AI assistant that is running on like on Alexa, for example, or an IVR system that is basically you interacting with an assistant through a phone, what you will have is basically the automatic speech recognition. Here in this first step, as you can see, which is a common use case, you are seeing AI already. And what does this basically is transforms voice into text. Just transforms the waves and the audio file and all that stuff into just pure text, raw text. And then once we have the text, we have to recognize that part of the text. Like we are requesting information about something, the assistant should know that we are requesting information and about XYZ. So that process is called natural language understanding. Okay, where when we extract that information from the raw text that we get from the automatic speech recognition. If we are in if we are creating a conversational AI app that is not like the input is not voice, we will not have the automatic speech recognition, but then we will have the natural language understanding. Then and after that, again, following the same example, if we are creating an Alexa application or an IVR, once we get the information from the user request, and imagine that, you know, like we're requesting the weather from Madrid, and we find and search that information in a using a webhook and consulting and querying an API. Once we get that information from the external source, we have to reply to the user. In those voice interactions, what you will see is basically, what you will have to use is a text-to-speech service. Again, in this case, this is there's artificial intelligence, because we are transforming text into voice, and yeah, like that is something that you will see and that you will use. And then finally, to create more natural interactions, basically, there's the generative AI, which is basically we're going to auto-generate text or speech using prompts based on current conversations, like for instance ChatGPT, and using the power of the large language models. All these services like the ASR, NLU, TTS, the Gen AI, everything is available in all the most important cloud providers like AWS, Azure, and Google Cloud. So yeah, just to try to understand like how to put all these processes in a request. For instance, let's say that we have this example, which is a person telling that he forgot the account, okay, and he wants to talk with an assistant, with a conversational AI app. So for that, the user will talk with the assistant. The assistant will be listening. At that time, the automatic speech recognition will happen. So it will transform the audio into text. Once we have the text, we will extract the information of that text. For instance, we will recognize that the user is requesting the password reset. Okay, that is when the natural language understanding is happening. Once we know what the user is gonna request or is requesting, we can have, for instance, like a dialogue manager that with the current conversation, we will navigate from one state to the next state. You know, for instance, from the initial state to the reset password state, like seeing the dialogue management as a state machine, and moving from one state to another. Imagine that the reset functionality is executed and the user gets or our system now knows how to reset the password. At the end, is gonna, like the final step, that is gonna happen is the text to speech, which is basically the transform the text into audio, and then the user what he or she will hear is basically like, sure, I can help you resetting the password. So basically this is the whole flow. And as you can see here, we are seeing ASR, we are seeing NLU, and we are seeing text-to-speech. So that is why you are seeing at the bottom the machine learning and the deep neural networks. But there are more processes that are also important when we are talking about conversational AI. The first one, and for me is one of the most important as well, is the context. When we are talking about context, is basically with the current conversation, everything that is like you can say that is around, like for instance, like how is the user feelings at that moment. For that you can use sentiment analysis models to understand how is the user feeling with the interactions that are being that are happening between the user and the assistant. The sentiment analysis models is also a AI model that is being executed. The location, it is important to know that, for instance, when we are talking with an IVR system through a phone and we are in the street, is different than if we are at home, or if we need like some urgent help because we are somewhere. It is different than if we are at home. The hour of the day, the day of the week, it is different. The interaction, or it could be different, the interaction, if we are requesting something during the weekends rather than during the work days. The language, the dialect, the actual noise, the tone that is being used. So the context in terms of the conversation is super important. It's like when you are interacting with other people, you can see that it is important to understand the context of the conversation, to try to know how to move in the conversation. So we told yesterday, there's the conversation manager, as a state machine. So with the context, we can use that information to move from or to move in that state machine, in that conversation manager. And then the other one is the multimodality. The multimodality is when we are interacting, for instance, with the Echo Show or the Nest Hub, the Google Nest Hub. In that case, what you will see is basically that you have a device that you can interact with them using voice, and also interacting with a screen. Okay, so when you are mixing more than one input, is basically when you are or when you have multimodality. You can also do that when you are interacting with sensors, for example. For instance, let's say that you have some sensors enabled, and those sensors are connected to your smart devices. In that case, you have multimodality as well. So how natural language understanding works? As we said, the NLU is one of the key pieces here in the conversational AI. So basically, for instance, in this example, tell me the weather of Madrid, which is the same example that we were talking before. We are requesting the weather of Madrid, okay, basic, as you know, and as we mentioned with the natural language, with interactions and using natural language, you can request the weather in so many multiple ways. You can say, tell me the weather of Madrid, sorry, can you please give me the weather of Madrid, weather of Madrid, or just Madrid, if we are using the context and we know that we are talking with an assistant that will give us the weather, for example. So those multiple ways of interacting or requesting the weather are called utterances, okay? But at the end, those utterances are requesting the same, which is the weather. So the intention is always the same. So from multiple utterances, what you will have is an intent. If you are gonna use any NLU, like for instance the one that we have at VoiceFlow, on Dialogflow CX, or on Alexa, or on Rasa, what you will find is basically intents, like get_weather, and then you will get or you will put there all the different utterances. And then on the right side, what you have is Madrid, which is a variable, something that could change. In this case is a city, okay, that is called a slot. That will some NLU engines call a slot, another one calls parameters, another one calls entities, but you will find it basically call or at the end is just the things that could variate basically. So generative AI. We mentioned the natural language understanding. We talk about automatic speech recognition. We talk about text-to-speech. And now it's time to talk about generative AI. For generative AI, basically when we talk about generative AI, we talk about large language models. Of course, there are more things related to generative AI, but specifically for the conversational AI live, we are gonna mention large language models, ChatGPT, prompt changing, and retrieve the RAG. Sorry. So yeah, basically when we talk about Gen AI, we are talking about mainly about LLMs like GPT 3.5 Turbo, GPT-4, GPT-4 Turbo, Palm, Llama, all these now very famous large language models. So what is a large language model? Basically it's a language model of a neural networks with billions of parameters trained on large quantities of unlabeled text using unsupervised learning. Okay, that is why it costs so much money to train a large language model, and that is why a large language model is super huge. And there's not like, for instance, you can run locally Llama, but the other ones are quite like impossible because you need specific machines to do so. And then we have ChatGPT, which is an artificial intelligence chatbot. It is a conversational AI app developed by OpenAI. It is using prompt changing, and this is the next thing that we are gonna talk about. Prompt chaining is basically a technique used in conversational AI that use the output of one prompt as the input to the next prompt, or part of your as a part of your conversations. Basically, when you have a prompt, this is what ChatGPT does. Basically, you have a prompt and you have an output. Then once you are continuing interacting with the chatbot, that output is gonna be used as a context for the upcoming prompts, for the upcoming interactions. Is in the same way, like you can see this as a when you are interacting with a human. Like for instance, when you start a conversation and you are explaining something new to a friend, at the very beginning you will not see or your friend will not know anything about the new topic that you introduced to him, but at the end of the conversation, since he has like more context, he will be able to reply to you with more information. That is basically a prompt chaining in the real world. This is an example how to do prompt chaining in VoiceFlow. VoiceFlow is a platform, a conversational AI platform where you can design and run your conversations, and it is powered by large language models. It has natural language understanding, it has automatic speech recognition, and it also has text-to-speech. And you can implement prompt chaining in VoiceFlow as well. So for instance, here what we have is basically a state called welcome, and the first thing is basically we are gonna call a large language model to introduce or to give us a warm welcome, instead of saying always hey, hello, hey, how's it going, or like just giving 3 or 4 options that can be chosen randomly. We can call a large language model and giving also some context to give a warm welcome. Okay, then we are capture the answer, like what we are gonna request. For instance, in the example that we are gonna see, we are gonna request information about me, and then we are gonna call an LLM. Okay, the LLM, basically the prompt that we are gonna tell to the LLM is you are a voice flow assistant, an AI assistant that loves helping voice flow users. Answer the question, blah blah blah, and then in the context we are gonna have the last response and the last utterance. Okay, so with the last response, basically at the very beginning that is gonna be empty, of course, but in the last response we are gonna have is where we are gonna do the prompt changing, because everything is gonna be stored in this block is gonna be stored in the last response. So we are gonna have some prompt chaining. So let me show you the demo live here. So basically this is the flow here at voice flow. Let me close this. And let me show you how this works. Let's run the prototype, and we are gonna ask about me. In this case, who is Xavier Portilla Edo. Since there is no context, he will reply me that he does not know, because I'm not a public figure yet. Then if I copy my information from my sessionized profile, and then I can say, okay, so Xavier is or was born, blah 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 blah. Now when we call the large language model, he is saying that okay, now it has more context about me. So if I ask who I am, he will reply me with my information. You see, instead of telling me that that it doesn't know anything about me, we were chaining all the outputs from all all the large language model outputs, and giving them as a context of the large language model calls. Okay, so here you can see that now he's replying with my information, and here you can see all the context has all this information, which is my bio. Okay, because we were chaining all the things that I was telling to the LLMs, and also the output of the LLM we're using as a context. We're being concatenated basically. So that is generative AI with the prompt chaining. Now let's talk about the retrieval augmented generation. That is something that can be used in conversational AI apps, which is an AI framework for improving the quality of large language models generated responses. by grounding the model on external sources of knowledge to supplement the LLM's internal representation of information. What does this mean is basically in the conversational AI apps, what we are gonna upload is basically our knowledge base in terms of like documents, websites, and also structured and unstructured documents. Those documents are gonna be transformed into chunks. Okay, how are those chunks gonna be transformed? Basically, we are gonna call a large language model to run an embedding model. Okay, so that embedding model it will transform the documents into chunks, and that those chunks are gonna be stored in vector databases. Basically, we are gonna transform information, documents into vectors. Okay, so whenever we are gonna search in the vector database, we are gonna retrieve the nearest vectors to my query. Okay, so for instance, imagine that we have like a book of recipes. We upload that book to our knowledge base. That book is gonna transform into chunks using the embedding model, and it's gonna be stored in the vector store. That is the point number one here, and storing in the vector store. Now that is like at the design time or at the build time. Now when the user is requesting, for instance, a recipe about Spanish paella, for example, this is the number two. It will that question is gonna go through the same embedding model, and that embedding model that we have also the chunks and the vectors, we are gonna make a query to the vector store to retrieve the nearest chunks, the closest chunks of the book. Okay, so if there is a recipe about paella, it will be the nearest or the closest, and it will retrieve those chunks. Then those chunks are gonna be used to prepare a large language model prompt, like please tell the user a recipe about the Spanish paella, and use this information to provide the final recipe. And then the large language model, we generate the final answer. That is how the retrieval augmented generation works. It is super powerful, and yeah, that is something that you can find as well on VoiceFlow, on Dialogflow CX as well. And yeah, you can use it locally using LangChain as well. LangChain is probably one of the most famous frameworks out there to play with large language models. Impediments with the generative AI, basically the testing is more complex because the outputs of the prompts are non-deterministic, and then are auto-generated prompts without control that can cause hallucinations. So you have to create a really good prompt to avoid those stuffs. And then privacy policy problems. So what is a contextual design? That is something we mentioned before, the context. So context is important. So for instance, in this case, when we are talking about jam, it's not the same, or the meaning of jam is not the same if we are talking about traffic jam, we are talking about fruit jam, or we are talking about music jam. Okay, so that is basically the contextual design, trying to design your conversation based on the context of your users. Here are some tips. Basically, it's design by thinking that every interaction should not be the same. For that, you can use generative AI, but basically making that every interaction is unique. Like as I said here, like create a wow effect on every interaction. Checking multiple variables that can affect the conversation. for instance, like as we said before, like location, first time interaction, hour of the day, etc. Talk with the assistants, not at them, because in the same way that we are talking with humans, not at humans. Be personal, individualize your entire interaction, store information from your users in external databases that you can retrieve, and then you can pass that as a context in your large language model prompt, so you will have a personal interaction and also adaptable. Okay, talk to your users in their own words. So for design tips, basically what I usually recommend is design your assistant. For instance, you can use VoiceFlow for that. Design, build, train, and evaluate. Okay, test, and test always. And finally, this is like the whole point of or the whole process that I should follow, which is basically having an idea, having a starting point, design the voice conversational interface or the chatbot conversational AI user interface, develop the backend if you are gonna call a backend, unify the voice user interface and the conversational user interface plus the backend, unify both, test, add some branding, and publish or deploy that to production, basically. And yes, the conclusions basically is understand the final users, validate the designs before going to production. At the same time that you're developing, create deliverables for your designs, and use tools that simplifies your lives, like VoiceFlow, for example. And always test. For the recommendations, please follow all the Google developer experts in ML like me, and other Alexa champions like at Kini Software, Kini Nevesábalos, Clara Jiménez, or Javier Campos. Follow my social media accounts, the Google developers, and Women in Voice. And if you have questions, I will be here to help you. And that's it. Thank you very much. See you.